Welcome back, Bifrosters. Here is part 2 of 3. So in this part, we've already set up all our points, we've done all our scattering, everything's looking great. Now it's time to build some wind and some grass instances. So watch on and enjoy. Cheers. Okay, so we've got our points in. Time to start doing something with them. The first thing we're going to do is we're going to build our grass and wind system. So for that, we don't actually need anything but the ground. Let's get rid of all of that. There we go. So presumably you all know what instancing is. We're going to instance some things onto these points. What are we going to instance onto these points? Let's go grab one of our display tools that we made, which will be one of these guys. That way we can at least have some size, etc. on our points. Maybe make them a little smaller. The brief here is we need a lawn. We also need a pathway on that lawn, which seems to have escaped our notice. So let's real quickly go and sort that out. Obviously, we didn't put a pathway in. It's going to be super easy. We just need to do another no points down. We need to grab a path, drag it in. This is the nice thing about setting things up as modules. We can just use them over and over and over again. All I'm going to do with the path shape here is I'm going to lift it. And I'm going to make sure that the path itself has some segment multiplication going on, otherwise it'll be very, very low res. And we have another no points down. Plug that into our build array. And here's our problem. Our path's a little bit too high. You can see, there you go, it has knocked out of that. It's not quite wide enough, which means we just jump in here, fiddle with our radius a little bit. So now we can hide this again, show this again, and there's our path. Quickly done. So what we need to do now is decide what we're going to instance on here. So I'm going to use some stuff that I prepared earlier, and I'm just going to really quickly walk you through it. If this was in a studio, you'd be given assets to do it with. But what we're actually going to do is scatter meshes. I've gone ahead and made the meshes in Bifrost based on a couple of real-world examples. One that I downloaded off TurboSquid, which is, thank you TurboSquid. It's fantastic. But you obviously in your studio environment will use whatever assets you're given to use or whatever assets you can find or are asked to find. So here is what I used. This is pretty simply doing nothing much but building a strand. Let's take a quick look at it. That's it there. At the origin, not looking very happy. So the way I did it is I have built a strand using a Bezier compound. And let's just really quickly set that back up. So if we put this up to 1 and we put the middle point at say 0.4. So this is just a little compound that basically builds a strand. Let's go in here and I'll show you how it's done. You have the input coming in. You have some settings for randomization of the strand. So I can bow that outwards along the X or along the Z. For the stylization, I can bend it. That, which basically just moves the top up and down. I can change the strand's profile, which is how thick or thin it is along its length. These are all strand tools, and this controls how many points there are in there. So if I say have 3 points, it's a lot chunkier. If I have 16 points, it's a lot smoother. And then I've got a master size multiplier, which is controlling the entire thickness of the strand. Here's the Bezier compound. And the way that works is just by looping. Feel free to look up Bezier math to get your head around that. That controls the resolution, that sets the profile along the length of the strand. That updates the ratio. That's very important. The point ratio is something we'll be concentrating on very, very heavily because it's very important to the final result. We've got the shape. We set the color based on the point ratio down here, and out we go. Because I was building this without a clear idea of how I was going to use it, I made sure I put out everything. But really, all you need is the raw strand. And the raw strand looks something like that. It's just a single line with the curve in it. So that's pretty much the first thing I'm going to scatter on these points. And this is to achieve the look of a field of cartoony grass. So nice thick blades coming to a point with a bit of a bulge in the middle. And here is the thing about instancing. So if I was to take my points and throw down a create instances, that's pretty much doing what it says on the box. It is instancing each of those strands onto one of those points, and they're all doing what they're supposed to do, but they are also all identical. Now, that doesn't matter terribly much because we're going to wave them in the wind, but it's probably good to get a bit of variation in there. And the easiest way to do that is to put these into a loop and feed in different settings here. So let me show you what I mean here. If I take just a simple for each loop, copy my strand builder inside of it, let's say I want to have 4 different strands. So what I can do is I can start setting random numbers and random profiles here. Some things I'm going to keep the same, the master size multiply, the strand resolution, but the profile and the 3 bends, the bow and the bends, I'm going to change. I'm going to leave the start, middle and end point the same as well, because right now I might maybe move that up to 0.5. So how do I get a random number in the loop? If I want a random number between, say, 0.09 and 0.27. Then I put those into the minimum maximum and I plug the current index into the seed. And that's going to give me a different seed number every time, which means I'm going to get a different random number every time. We can plug that into the X. We can copy and paste this and change these numbers. And now, with this for each, we should probably output something. Let's output the strands for now. That's all good, just so we get a quick visual representation. If I remove this from my instances and plug this in, you can see I have got slightly different strands all over the place. Let's make that a little bit more obvious, shall we? So I'm going to take one more random value and let's change the indexes of these as well. So that's index 0, that's index 1, you can see them change. And this can be index 2. And if I take the bend strand and just test this, this will give me a height variation, which is great, that's what I want. So let's go for a minimum of minus 0.1 and a maximum of 0.1. Plug that into the bend. Now they're all the same. And I bet you're wondering why, and that's because this is reading them sequentially. Let's make this random. Let's go in here and make this variation quite a bit bigger. So now you can see some are low, some are high, some are bent one way, some are bent the other. This just gets us a very, very quick variation on all of this. And why don't we indulge the zeros as well? So now if you can see that we've got quite a bit of variation in this just with 4 different strands at the moment. And as I said, we're putting a field into that. I can also make these random as well. There's no reason I can't take one of these, change this over to a MathFloat 3, and then move our middle point or move our end point. So let's move our middle point. So the minimum, say, the minimum is still a float. So minimum 0.333, maximum 0.667. Put that into the middle point. And it's slight, but you do get variation. So that's basically how this is set up. And the reason it's set up to deliver 4 or 6, and you can see them change, is the instancer takes a certain amount of objects and it instances them on the points with rules, which is what we're going to get into and why we're just really quickly running through instancing again. So the last thing we want to do is change the profile. And we want a certain number of profiles. Don't forget that we have quite a lot of points here. And what gets even worse is we're going to scatter on these strands. So let's just create a value node, which is going to give us this curve. What I'm going to really quickly do is just duplicate that 5 times, come in here and start making changes to it. Now I need to find a way to randomly select one of these every time we go around the loop. The first thing I'm going to do is build an array out of them. Then I need to pick a number between 0 and the end of the array based on a random number generator. We're going to get the array size, we're going to decrement that by 1, and we're going to choose a number within that space. And you can see how that's worked. We've just got different shapes and thicknesses, we've got different heights, we've got all kinds of different things going on. It's looking a bit like an overgrown lawn. Let's get the setback in there so we can get a sense of scale. And it's definitely looking a bit overgrown. So let's make that a bit smaller by changing the values on our bend strand. Let's make sure this doesn't quite go as high. Of course I can get a much bigger spread, but we don't want to get them too short. Check from the camera. So that's not looking too bad. It's a little bit overgrown. We can maybe change the master scale on everything, which would just be a matter of grabbing this once we've got something that's looking reasonable, and this is looking reasonable, they're all different. They're all a bit big, but that's because we now start to set up how our instances look. Let's just name this. And let's set up some randomization on our instances. Now, I have put randomization in here, but we'll need to randomize point scale on our actual instances, on our points here. And what this does is it assigns a random scale to each point, and you can see immediately that that's looking a lot more like sort of a messy grass. It is now very much too big, and that's easy to fix. So let's just pull this down. We want it to be at about that level. And the really nice thing about this is you can eyeball it. You can adjust it until you're quite happy with it. And I'm quite happy with it. And to make it even more random, what we're going to do is randomize the rotations as well. So that's probably a bit much. And you can see here, this is done in radians. X and Z radians are leaning over a little bit, or a little bit this, but the Y radian is what we're looking at. And this is doing between negative pi and pi, which means it's doing a full rotation to randomize. And that's probably a bit much. What does it look like with 180? Still a little bit too much, so we can just pull this down until we get something that's a bit better. Something like that. Or, of course, you can, if you decide to, you can get rid of it altogether and not do any rotation, which is indeed what I did for the render. But that is available to you if you want it. So now we've got something. Let's go to our shot cam and take a look. And that's looking pretty good. We have a seed for the random here that we can change as well, if we want to get a slightly different look. We have a seed for the scale random that we can change, which will deliver another different look. We can change the distribution of the scale. We can change the way it scales with uniform separately, etc., etc. But I'm pretty happy with that, and it's time to go on to the next one. So like I said, I'm not going to show you how to build the other two. I'm just going to bring them in. Let's get this working straight away, and then we'll actually start talking about some of the new improvements to the instancing that we're going to showcase. Use one of Maxime's awesome nodes in the MJCG 2.0 pack. Huge credit to Maxime. I'm going to extrude these strands and then put them out. Now they're meshes. They're meshes with UVs, they're tubes in this case. What I want to do, because I'm going for a little bit of a cartoon look, is I don't want them to be tubes, I'd like them to be ribbons. Now you're looking a little bit more like grass, like that. And the reason I convert them into a mesh is so that I can then scatter on them again, but that's for a bit later. Just update their normals to make sure all their normals are okay. And now I've got this looking at me here, I can see that they all look a bit thin, which is why I have a master size multiplier. We'll just fatten them up a bit. So they look a little bit better. Some of them are thin because they're side on. This might be a time to put a randomized point rotation on if you wanted to. But I know that what we're going to do is scatter points on these meshes and grow crystals up them, and the crystals are going to be fairly fat. It's not really going to matter too much how these look. You're going to get a few seconds of the render of them, and then they're going to be covered in crystals. And I'll just bring in the other two. And we're back with a few adjustments. Now we have our base scatter. As you can see, I have the grass with a couple of additions. So there's our base grass. Here is a reed. And this is, if you take a look inside this, the reed generator here, basically this is just copying what the mesh looked like, but in Bifrost. So it's a single long curve with a bit of a noise field on it for displacement, which is why there's a seed input here, so it changes each time through the loop. Then we add some points to it after updating the basis, etc., things like that, and setting up some controls for the percentage of the length that we want the fluffy bits on the top. This is more inputs here, but at this point we generate these parts here, and in here is hidden away another scatter and another instance. So we're just instancing a little object on these strands to within a certain percentage of the top to make it behave and look like the fluff on a reed. And then also we are putting in a maiden grass instance. And again, this is done in a very similar way. Working from the curve, which is the input here, we're generating one single maiden grass by making sure all our ratios are okay, building the curves that come off, so whether we want 2 or 3 or 4 or whatever, extruding those to give them some weight, and then as we come towards the end, all right, a little bit far towards the end, we're also instancing in here as well. Scattering here, creating instances, and that's just this mesh plane or just these little bits up here. So we're relying fairly heavily on texturing, but then we never really get that close to this, and it's supposed to be stylized and cartoony anyway. So that's cool. I can, if I want to, just put all of these into the instance and work with that. That's definitely one way to do it. I can change my probability curve here so that we get more grass than almost anything else. But there's a better way, and I'll take you through that now. So just as a quick recap, we've got our grass generator and we've got our 2 variant generators. So what we're going to set up here, let's just get the reed and the maiden out of there for now. So we've just got the grass. So what we're going to set up is a selector instance. And what a selector instance lets me do is I can put in the reeds into there, and I can put in the maidens into there as well. And then I can plug that into my create instances. And you can see what's happened here. Don't appear to be getting any reeds, but that's all right. We're working on that in just a second. Point of the matter is we can put as many different instances as we like and control them after the fact, which is what this part of the workshop is all about. So let's get on to that. Okay, so we've got our grass looking a bit better, and we have our 2 extra instances set up. What I'm going to do with these 2 is I'm going to set up what's called a selector instance, which will basically give us the ability to plug these 2 into a selector instance, plug that into our create instances, and then adjust probabilities of what turns up later. So I'll very quickly lay that down, and then I'll talk you through it. And there we go. So now you can see what's happening here. I have 3 instances in total. I have the 4 grass that are being generated. I'm having the 4 reeds that are being generated and the 4 stalks of maiden grass that are being generated. The latter 2 are being plugged into the selector instances, which is just gathering them all together and putting them out into the create instances. And here's the special sauce. After the create instances, we're using randomized selection by probability nodes. And what these are controlling are based on the property going into it. So the property coming into the first one is the point instance ID. So what this is controlling is 1, 2, 3, 4 grass variants coming in here, and then the probability of the entire selector instance, which is coming in second. So we have 4 inside of here. We only have 1 in here. So this is controlling the entire probability of that. I'll just leave that back at 0.2, just because we don't want too many of them. The second one is being controlled by the point instance variant ID, which is what's been plugged into the selector instance to distinguish. And here you can see we have a probability of all 1s because there are 4. Yep, there are 4 coming out of the reed, so there is 4 reeds, and there are 4 coming out of the maiden grass, so there are 4 maiden grasses. And I'm giving them all an equal probability of showing up. So the first 4 are the reeds, 0 to 3, 4 to 7 are the maiden grass. And it's at this point where we've got the look the way we want. We've got an awful lot of control over our instances now, so I can still play with things like this and get a different look, but I can definitely start changing probabilities here, and that gives me a vast amount of control over, do I just want mostly grass? So we can just take that all the way back down till it suddenly just becomes all grass again. Do I want, quite a few of those, maybe probability of a half? And inside of that, do I want to say have more of the second one, more maiden grass than I do reeds, and again I can control the seed as well, which will just change things but never the proportions. So that's really the layout of the instancing. It's at this point in time where we're needing to start to think about making these guys move. I'm pretty happy with the lawn as it is. Eventually what we will do, these two at the moment are meshes, but this is a strand. So let's go fix that. And we fix that by, we've already set up the basis of it. We'll just replace the output with that. So obviously I need to do some size adjustments to get these to match. There we are, that's looking a little bit better. And we need to make sure, for applying a distortion to this later on, that these have a point ratio coming out. Now, the strand does, if I was just to plug those back in, those do have a point ratio, but the mesh here does not. So we need to create a point ratio for this mesh. Luckily, Maxime in his infinite wisdom has left us the way to do that. We can transfer the properties through his extrude. So if I take this and go point ratio, now that turns up, which is excellent because we'll need that to apply a wind to it. So let's really quickly, just so we can get an idea of what's going on, we'll make another tool that'll allow us to see what our output looks like with a point ratio and a color on it. So if we just jump back in here very, very quickly, and I'll set that up and then take you through it as per usual. And there we are. So now you can see, if I select these, you can see that they're now all meshes. And you can see that they get a little darker at the bottom than they are at the top, which is what the point ratio is doing. And this just gives me a very, very quick visual reference. I can look at it and see where the point ratio is lower and where it's higher. The reason we do the point ratio is that we're going to deform all of these with a feel. And if the point ratio is 0 at the bottom, we can use that as a stiffness calculator. And we can also adjust it later to get more or less bend in the grass. And all of these are the same. These have already got the point ratio set up on them. We can take a look in here. What we're doing is assigning a diagnostic material. So we need to jump in here and see where we're assigning to the reed. And this already has display point ratio set up. Yes, you can see that they are also get darker at the bottom than they are at the top. So that's our lawn setup. That is the major piece of instancing we have to do right now. The challenge now is to get points on these and to get everything to move. So move, like you saw in the render, move in the wind. So to do that, what we're going to do is we're going to take some time now and set up the wind field and just tweak it until we get our movement looking right. And then we'll go on to scattering the points that we're going to go crystals from. But of course, before we can do anything with these, we have to bake them. And this is where we start to look at our optimizations even further. Right now, I can bake this. You can see how slow this is, and we lose all of our information, which is fine. What a bake does is it converts the points and the instances on them to full geometry. And let's see what attributes have come through the bake. Looks like most of them, but most importantly, the point ratio has come through, and that's what we need. And the color has come through, yet they've gone blank. Well, the colors are there. The normals have been updated, and I'm using the most handy node in Bifrost, which is Force Pull Port from the Rebel Pack. This is forcing this to calculate and showing me the data. So right now we have about 5 million points in there, which is why things are getting pretty slow. In and of itself, that's not too bad. That includes all of the points on all of the meshes and things like that, but it does tend to slow things down quite a lot. So quite apart from our color problem, which I will have a crack at fixing in a minute, we need to find a way to make sure that this doesn't calculate every frame, because we want to start displacing all of this now, so it looks like it's moving in a wind. And if it has to calculate this every single frame, it's going to take quite a long time to work. So let's go ahead and put down a really quick and easy way to cache this by using a port feedback. As usual, I'll whip that down and then I'll talk you through it. our meshes come in through the input, and then the time, so where we are in the animation, is tested to be greater or equal to this value here, which is going to become our start frame. If the time is greater or equal to the start frame, we're going to use the feedback port. If it's not, that means if it's less than the start frame, we're going to use the input. And what a feedback port does is it sends out from here the result of this calculation, which in this case is there's no calculations being done. It's just choosing which one to go through. So this one is being calculated, but this one gets its input from here, so it's not calculated. What this node is doing is on a certain frame, or below a certain frame, it's going to calculate this input. But above or equal to that frame, it's not. It's just going to replay what it's got. And that's essentially the same as caching it. There is a Bifrost node to do it, which is compute on frame. But I thought it'd be good to know how to do it ourselves as well. I'm actually just going to use compute on frame because it's easier. But that's the idea. We're going to take our meshes, put it into compute on frame, and it's only ever going to compute on frame 1. And I can show you this by going to frame 1. Letting it calculate, then any frame after frame 1, it's not calculated. It takes a little while to calculate on the first frame, and after that, it's absolutely smooth. And what this essentially enables us to do is bake all of our instances, and then anything we do to them after frame 1 won't be calculated again. And this just speeds everything up immensely. So let's fix the color. So we've got our green back, but we appear to have lost our other ones. Our troubleshooting. This is all just for us to keep an eye on it, so I'm going to leave it like that for now and maybe fix it up later. I'm going to plug this in so that we have some speed. But at least we've got the greens back on the grass. Now that we've got our lawn looking the way that we'd like it to look, which took some messing around, I have fixed the colors. And the way I did that was by fixing the colors inside of here, all the way inside to where it generates. And there we go. Set geo color. The problem was that the assets I brought in were using point color and not color, so they went black. Now it's time to generate the wind field. We want these guys to be moving. Here's a one that I prepared earlier. And at this point in time, with the speed of how things are going, we do have a lot of points scattered. We're going to need to start relying on things like play blasts to get an accurate visualization of what we're doing. You can see that they're moving, but it's playing back at 2.3 frames per second. What I tend to do is I will play blast it, like so. And this will take a little while, but I'll give it maybe 20 frames, 25 frames, and then I'll stop it and take a look at what the result is. There we go, let's just stop that there. Pressing escape, and it will load the frames that it managed for you. You need to give them a minute to load into memory. And then you can get a better idea. So it's not that many frames, but I can see that the movement's pretty much what I like. And what I'm going to use, I'm getting some stiff movement from the grass, which is all good for grass. If I wanted to change that, I can. That's just beside the point. What I'm going to show you now is how to build and apply the wind field to these baked geometries. What we have to think about for a wind field is how wind works. You've got moving air that's moving across this object and making it move. You don't need to get into the physics of wind, but learning how fields work is a really good idea. So let's just get this back to still. And because we've used compute on frame to cache this, it's everything except for the first frame, the frame to pull on, is a lot faster. So if you wanted to reset everything, you go back to 1, give it a minute to calculate. There we go. But I would recommend that you jump 1 frame forward so you're not calculating all of this stuff when you build your wind field. So first we'll need a compound. Let's dive in here and I'll build the different sections of it and explain as I go. First thing we need to get is the point position of our grass. Let's rename this. We get the point position for 2 reasons. One is that we need to sample the field at those positions. So this is every point on the grass, and I believe it's millions of them. We need to sample the field at this position, and we need to use this later to reapply on. So we're just going to keep this for now out here, but before we do any more to the object, let's create the wind field. I don't need the object coming in for this. I can create it all in here. To see the effect of the wind field, we'll need to attach the object and work from there, or use a field scope. But for now, let me just show you how I'm doing this logically, and then we'll hook it up and tweak it as we need. First thing I need to build in the wind field is the wind direction. And I want a random direction. I want these to move randomly, but then I also want them to move in a non-random direction as well. And that makes things just a little bit difficult. So I'm going to construct this based on my very good friend and field mentor, Roland, who showed me how to do this. Big shout out to Roland there. So the first thing I'll need to build is the direction. And because we're working with fields, I'll need a kill noise field. And this is going to give me a nice random direction to my field. But because I don't want it to be too random, I'm going to add a vector to it so that it's always moving in a certain direction and still providing a random kill noise. So the vector here becomes our first input, which is our wind direction. And that's really all you need to do for the direction of the wind. That's really all you need to do for the direction. A kill noise field, a vector added to it, and out it comes. The next thing we'll need to build is the strength of the wind. And as you notice here, this is a vector field, so it is producing vectors. This is a scalar field, so it's producing a value. So this is how fast and in what direction the wind moves. This is how strong the wind is. Now the thing with a fractal field, a fractal noise field, is this gives an output of both positive and negative numbers. So it goes from roughly -1 to 1. First thing I want to do is make that always positive. I'm just going to add a little bit of a number to that, just to push it up over 0. This is now giving us a fractal noise field with a magnitude and a frequency. This will control the strength of the field. We also want to be able to control the strength of the field ourselves. So if we just take this as our fractal noise strength, which means it's different across the entire area. So we're going to multiply that by an input. So now we have the two aspects of our field sorted out. We have the direction, which is nice and random, with a little bit of added user direction. And we have the strength, which is also slightly random across the area, but can be controlled by another input. To get the final field out, we need to multiply. We multiply the direction and the strength. And if you're following along, that's surprisingly similar to a vector. You have a direction and you have magnitude. Not even surprisingly, what we're creating is a field of vectors here. If you take a look at that, it's a vector field output. Now we could put this out to the grass right now and distort it and everything would work, but we'd have almost random everywhere stuff. We'd have a little bit of direction based on what direction we put in, but let's actually make that a bit stronger so it looks more like wind. I'm going to translate my field by my wind direction, with one change being that because we're working in an area where we have grass, if you think about how grass works, grass doesn't stretch up and down. It moves from side to side. So what I need to do is knock out the y component of this vector. And I do that by multiplying it by 1, 0, 1. So the x and z components are unchanged. The y component becomes 0. This means that my grass won't distort up and down. And that's the wind field made. Right now we can't see anything. Let's just rename it. And because of experience, I'm also going to make sure that we have control of the noise field magnitude and the noise field frequency. Wind field is made. Now, how do we apply this to our points? What we're going to do is take the point position, sample the field, multiply that by our point ratio so we don't get too much bending or movement of the bottom points, and then reapply that to the point position. So I'll get that set up now. And that's done. So we have our wind field being generated here. We have all of our controls to control that, which we'll be needing to go over and tweak in just a minute. We're getting our point ratio, which is represented here by the color. Where it's black, the point ratio is 0. Where it's a color, the point ratio is 1. This will allow us to change how stiff the grass is. So essentially, because we're multiplying our distortion field by that number, when it's multiplied by 0, it won't change. So 0 will go and be added back onto the positions. When it's 1, it will change the most. So we're sampling the field at that position, we're multiplying that by the point ratio, we're adding it onto our position, and then setting our point position again. Now it's time to see what that does. You need to make adjustments to get it to look right, and the first adjustment you should probably make is how strong that wind is. And you can see that the wind is quite strong. Now I can play this. The wind's also not moving right now. But this is the strength of the wind. What we also need to put into our wind field is a way to change this stuff over time. So we're going to need to add a time node in here. Right now we are distorting this grass in a direction and a magnitude, but it's not changing. So we need to change this field over time. But I can tell you straight away that that's going to be way, way, way too fast. So what we're going to need to do is add a wind speed property. And of course it would help if our wind speed is greater than 0. Let's try 0.1 to start with. See what we get. There you can see the wind field working. It's rather too large right now, but at least this shows us. This would be a very windy day. It shows us a couple of things, that the wind field is working and changing. If I play that, you can see it changing there. But also that our point ratios are working. Everything is still remaining at its 0 point, and it is bending according to its point ratio. First thing we can do is change the magnitude, so it's not so big. We can change the frequency is fine. Change the wind strength to right down, so it's very, very small. This might be so small that we can't see it. It is so small that we can't see it. So there's always a bit of dialing in to be done with this kind of thing. You can see it's starting to work now. So what I'll leave you to do is just work out what looks best for you, and I will go ahead with the one that I made before, which is exactly the same thing. That generates the wind field. You can see the wind speed, strength and direction, and you've got your outputs here. Applying the field does the same thing, where you've got the field being sampled, multiplied by the point ratio, and I've adjusted that point ratio just a little bit. You can also do that by putting in an F-curve, multiplying the field value by the point ratio here, adding it all back on and setting the point position. So I'm going to hook mine back up, and you can grab the settings off here if it helps. And now we have the wind field. And there you have it. Instancing deep dive, plus some fields, good looking wind, stuff blowing around. I hope it's been informative and that you've enjoyed it. And I hope you're ready for part 3, which is quite a lot longer, 3 times longer. So let's get on to that. Cheers.